am I doing? DIFC, physics, materials, and that is lesson.
I have it.
You have them open?
Yeah.
Okay. Well, it's still loading for me, so I'll just open it as well anyways. Okay, well you have it, so I don't need to have it open now, thank you. Did I do any of the questions last time?
No.
No, okay, so number
1. Student drank 1 cup of coffee.
Yes. How many cups of coffee in moles?
How many moles?
Yeah, so you have, goodness gracious. You have 1 cup of coffee, or just 1 element, and you can convert that into moles by just changing this into 1 over. Hold on, don't confuse me. 1 over mole times mole, and a mole is Avogadro's number, so it's 1 over 6.02 times 10 to the 23 moles. Musharif, what number is this?
1.
No, 1.6. What number is this? I don't have my calculator.
Oh yeah, 1.66 times 10 to the minus 24.
Okay, great. Oh, come on there. Now let me just check. 1 over 6.02 times 10 to the 23. Excellent. Oh, minus 24. Not 24. Of course not. Minus here. Okay. Okay, nearly. Yes? Okay. Number 2, please, Musharif.
Air is 70% nitrogen and 30% oxygen.
Now just a second. Oxygen is diatomic, isn't it?
Yeah.
Is nitrogen?
Yes.
I gave you the table in the last class. I think it is diatomic.
Yeah, nitrogen is.
Okay, so go ahead. Oh, this is what is the, and then I give you the molar mass of each, don't I?
No, that's what it's in the one.
Oh, well, yeah, that's what I want, yeah, but I give you those in the table.
Yeah.
So I want the average molar mass.
Yeah.
So this is a bit like relative atomic mass. It's 70% nitrogen, 30% oxygen. So an air molecule, on average, will have a molar mass of 0.7. Do you prefer 0.7 or 70?
0.7.
Okay, then I don't need to divide by 100. You either use 70, 30 and divide by 100, or 0.7 and 0.3. What's the molar mass of nitrogen? 28. 28?
Yeah.
Okay. 28 point.
0.
Yeah.
3, 4.
And then oxygen?
0, 1, 3, 4.
Oh, it doesn't matter. Doesn't matter. What's oxygen?
31.99. Yeah.
Okay, so 0.7 times 28.0134 plus 0.3 times 31.9988. And the molar mass is 29.2 grams per mole. 29 grams per mole. Okay, that one was, I know it was a bit confusing, but is it okay now? I know you had a bit of trouble last time with that.
Yeah.
Yep. Okay, what's number 3 then?
Cylinder of R1 is at pressure of 1.5 atmosphere and its volume is 50 liters.
50 litres?
Yeah. What will be its pressure if the volume is reduced to 40 liters?
If the volume is reduced to
40.
40 litres.
Yeah.
So, here, this is an example of Boyle's law, where pressure is inversely proportional to volume. So, what do you multiply 50 by to make it become 40? You'll multiply it by 4 over 5. In other words, the pressure, the volume has been reduced by to 4 fifths. So, what will happen with the pressure? It will increase. Do you want to?
5 over.
Yeah. 5 over 4. It has an opposite relationship. So, 1.5 times 5 over 4. And you get 1.875 atmospheres. Okay. What's next one, Musharif?
I want to
Go on. Huh? Oh, you need to write, sorry.
yeah. No, okay. You can say it. A tank of oxygen is kept at pressure of 3 atmosphere in a room at 20 degrees. If the tank has volume of 100 liters, then how many atoms of oxygen are in the tank?
Great. So, first thing I need to do is convert that 100 litres into meters cubed. So, if you recall, we said 1,000 litres makes a meter cubed. So, 100 litres would make a tenth of a meter cubed. So, the volume is 0.1 meters cubed. And we have good old PV. Now, do we want atoms? So we want small n or big N?
Begin.
Big N. So PV equals NK T. Boltzmann's constant. Does anyone have the Casio calculator? Perfect. So, just a second there. N equals PV over KBT. Now, Boltzmann is in the formula book, but it's also on the calculator. Do you see a KB anywhere? Yeah. It might be K as well. If there's no KB, it could just be K.
There is a K, yeah.
There's only one K?
Only one K.
Then I'd say it's that.
And it's right underneath NA, so it's fine.
That makes sense then, yeah. Now, let's type this in. Pressure is 3 atmospheres. Oh, is atmosphere on the calculator? ATM?
Yes.
Right, now watch, the calculator has these constants built in. So 3 atmospheres, and what number is atmosphere?
40.
How do I get constant? Shift 7, and number 40, and then you just wait a second, and it appears, multiplied by the volume, divided by, and what number is Boltzmann?
25.
Great. And then the temperature should be in Kelvin, which is 273.15, I think, plus 20. Okay, so we should get a really big number here, obviously. 7.5 times 10 to the 24. Is that right? Do I ask how many molecules of oxygen or how many atoms? Each molecule occurs in a pair, so I have to multiply this answer by 2. Yeah,
Oxygen.
because it's oxygen. Oxygen is diatomic, isn't it? So I take this and multiply it by 2, and I actually get 1.5 times 10 to the 25. That's how many oxygens. The previous answer was for O2s, not O's.
So you divide by 2 or
Multiply by 2. If I said I had 10 pairs of socks, how many socks do I have? 5 or 20? 20. If I have 10 pairs of oxygen, then I have 20 oxygens.
So the first one is molecules and the second answer is atoms, right?
Yeah. Okay, how many questions are there altogether? 6, okay.
What is the KB?
Boltzmann's constant. I don't know what it is because it was built into the calculator. I gave it to you in the lesson though. What number is it, Iyad? We'll just get it up here. Huh? 25. Here you go, Ms. Sharif. There it is there.
This is the KB.
Yeah.
Equal 1 point.
It's in the formula book as well for those students who do not have the recommended calculator, like Musharif. Where's your Casio?
Abdul.
Who? Abdul. Which Abdul?
Business.
Business Abdul. Who's he? Is he intake 1?
Yeah.
No, multiply by 2.
1.5.
The answer you have should be half of this, and then I multiplied it by 2.
But what is the half?
Oh, it was 7.5.
Oh, 7.5 times 10 to the 24.
7.5.
Yeah. Okay, what's number 5? Are you ready, Musharif?
In Ireland, the mean average temperature is 10 degrees. Your picture is given with driving a car that emits 119 grams of carbon dioxide per 1 kilometer of travel. The car is traveling at 120 kilometers per hour on the motorway for 1 hour. What is the volume of carbon dioxide released?
Okay. So the first thing is, how much carbon dioxide was released? Well, I tell you, it's 119 grams for every kilometre. I'm driving at 120 kilometers per hour, and I drive for 1 hour. So, if I drive for 1 hour, how many kilometers is that? 120. And if it's 119 grams for every kilometre, then the total mass would be 119 times 120, which is
14 and 28.
But it's gram.
14,000. So that's 14.28, like this,
Yeah.
kilograms. Yeah.
But it's gram or in
I converted it to. If it makes you feel better, you can do it like this at the beginning. Better?
Yeah.
Great. Right. Now we have PV equals N or T. And what am I looking for? The V, isn't it? So the V equals N or T over P. Now, I need to work out the N first.
Stephen,
Yeah.
why the mass is equal to 119 multiplied by 126 is that?
How many grams do I get for every kilometre? 119. I tell you this. How fast is the car going? 120 kilometres every hour. How long does the car drive for? 1 hour. So it drives for 1 hour. That means it travels 120 kilometres. That means it releases 119 120 times. So it's 120 times 119. You don't seem happy. I don't know what I can say. Yeah, do you get it? And
Yeah.
where?
Okay.
Yeah. It's okay? Sure. Thank you. Okay. So the pressure is what? 1 atmospheric pressure. The R we know is the constant. The temperature we know. So what's the only thing we don't know actually? The N. But we know how much CO2 was released. 14,280 grams. We can look up the molar mass of CO2, and by dividing, we have the number of moles.
44.
It's not actually quite 44. It's roughly 44. What is it in my table I gave you? It should be slightly less than 44.
Different to the sensing.
No. My one is more accurate. There's something you weren't told in the chemistry one to make your life easier. But usually, and we'll do this in physics later, usually when bonds form, like for example H2 or O2 or whatever, the mass is slightly less than the two original masses. So in other words, O2 does not have the same mass as two oxygens, slightly less. What is the molar mass? Is it on the table?
So will you be given the table as well?
No. It'll be given to you in the question if you need it.
Just one.
That's just all CO2, right? Altogether, so 2 times 14.
Oh, I don't give it to you. Then you'll have to work it out roughly. It's a carbon plus 2 oxygens, or the carbon plus the oxygen, the O2.
Oh, it's 108.07.
It's more.
108
Yeah.
point.
Wait, carbon dioxide alone, right?
Yeah.
Carbon dioxide.
Do I give you that in the table?
Yeah, that's 44 point.
There we go.
Yeah.
44 point.
0.095.
Okay, calculator time. So once again, 144280 over 44.0095. What is OR on the calculator? Should be 24, 25, something around there?
27.
27 times 283.15, and then atmosphere was, which one? 40, the last one. Right, let's see what we get. 76 meters cubed of CO2 released by this journey. How many liters? How many liters in a meter cubed? 1,000. So you could also give the answer as 76,172 liters of CO2 released by the journey.
Yeah. Why?
No, because remember, 1 meter cubed is 1,000 liters. So every meter cubed gives me 1,000 liters. So if I have 76 meter cubes, then I have 76,000 liters.
The gas,
Last one? Okay.
the gas of volume, for 0.050 meter cube,
Like this?
yeah, and at STP
Yep.
is placed in flask X dot A, no X and flask
Huh? Say that again. Okay, so that's some kind of container X, alright. So you put this gas into X, okay, dokie.
A is a second gas,
Uh-huh.
gas Y of Y, the volume, also at STP,
Twice the volume will be 100, okay. Also at STP, this is gas Y, is it? And then what happens? That's put into the flask as well.
is placed into flask Y.
Oh, okay, that's placed into a flask, a different flask, okay.
The flasks are now connected and
Then you connect the flasks. Nice.
gas X and gas Y combined.
Yeah.
What pressure will this mixture will be at?
Nice. Nice question. So, what happens here is you're mixing two gases together. So you're looking at the pressure for the combination at the end. So the good news is, well, the volumes will just add together. Which makes sense if you really think about it. If you have 1 litre and 2 litres and you connect the containers together, then you have a container of 3 litres obviously. So this will be 0.150 meters cubed. The temperatures and the pressures we'll worry about in a second. What else adds together? The temperature doesn't add together. For example, if this is 10 Celsius and this is 10 Celsius, and you mix a 10 and a 10, you don't make it 20, it would still be 10 for that particular example. So pressure doesn't add, temperature doesn't add, pressure doesn't add, but something else does add. N adds, because if you have N1 here and N2 here, then in total you'll have N1 plus N2. You know, if I have 100 moles of one thing and 200 of another, then I have 300 moles altogether.
But we have been given the standing temperature value. Like
Yep.
0 K and 1 atmosphere.
So we need to work out the N. Look, the N is N1 plus N2. You have PV equals N or T. So the N is PV over RT. So that would be P1V1 over RT1 plus P2V2 over RT2. You can take the R out. 1 over R, P1V1 over T1 plus P2V2 over T2. Now in the question I tell you what standard temperature and pressure means. It means a gas which is at 0 Celsius and 1 atmosphere, is it?
Yeah.
0 K.
0 K?
Yeah.
It will be 0 then.
No, 0 C I must say.
It's K.
Which is way beyond.
0 K. I think it's.
That's a typo. No. That's
Because the answer will be 0 then. Like.
and also the gas would be frozen solid at
No,
0
it's
Kelvin.
it can be.
It can't be. Yeah, no, that's totally wrong. Sorry, I meant to say 0 Celsius, yeah.
Then it's 273.
Then it's 273, yeah. And the pressure is 1 atmosphere? Okay, so let's just hit that in. Sorry, once again, Iad, what is the OR?
27.
27. So it's 1 over OR. And then we'll put in fraction plus fraction, and then atmosphere is 40. I remember you saying that now. And then this one had an atmosphere in it as well. Oh, and temperature is 273.15. Oh, actually, they're nearly going to be the same. The only difference is with the volumes. So the first one was volume 0.05, and then the second one was 0.100. So when you put the numbers in, you get 6.69.
6%.
Yeah, 6.69.
So one thing. We can also do the volume, like we can take the volume as a common.
Yeah. And you can also take the temperature as common as well. Yeah, it doesn't matter. It's okay. I'm looking for the final pressure. So PV equals N or T. So P is N or T over V. So the final pressure will be the final number of moles times the ideal gas law constant times the temperature, which we don't actually know, over the volume, which is 0.100. But we do actually know the temperature for this one, because this one's very special. When you mix two things at the same temperature, the result will also be at the same temperature. Now that only works if they're the same temperature. If I said one gas was 10 Celsius and the other gas is 20 Celsius, we haven't learned how to add the temperatures together. It's not going to be 15, because one gas is twice as big as the other. So if anything, it'd be more like 17 or 18. Anyway, in this case, the temperature is 273.15. So 6.69 times 8.31 times 273.15 over 0.150. So at the very beginning, the pressure of each gas was 1 atmosphere. I wonder how it will be affected when they're combined together. Let's see what happens. I wonder if it will also be 1 atmosphere. And that looks like 1 atmosphere as well, isn't it? 100 and...
No.
Roughly. It's probably because I was rounding off these two numbers here.
So should it be then?
I think it should be 1 atmosphere here. I did ask for the combined pressure, didn't I? At the end?
Yeah, it does.
That's what I want. Yeah. Yes. Yeah. So this is also roughly 1 atmosphere.
Random question. The intake 2 exam is happening next week. Is it counted?
Is it? No, it's just a mid-semester. So it's formative, just to get a idea of how they're doing. Yeah. Why? Who was worried about it? Who was talking to you about it? I figured. Yeah. That's okay. He thinks that they think I'm going to trick them, say, no, your grade, it won't count towards your grade, and then bam! Did, suckers. Okay. I've seen this question in section A. It's not too difficult. I thought it was interesting, that's why I included something similar to it. But I think I'll change it because it's kind of boring since the answer is 1 atmosphere as well. Okay, can I close this now? Got that, Miss Sharif?
No.
Oh, come on! You're killing me here.
The T1 and T2 are equal.
Huh?
T1 and T2.
Yes.
And T1 and T2.
1 atmosphere. Yeah? Great. Great. Okay, let's make it a little bit more interesting for the next student. Wait, this isn't it. What lesson was this? Wait, this one. Right, let's make it a bit more interesting for intake 2. A gas of volume 0.050 meter cubed and at standard temperature and pressure is placed in flask A of the same volume. A second gas Y, of twice the volume, I'm going to make it twice the volume, twice the pressure, but the same temperature, is placed into flask Y. No, that's stupid English. A gas of volume that and standard temperature and pressure is in flask X. That's better. a second gas, gas Y, of twice the volume, twice the pressure, but the same temperature is in flask Y. The flasks are now connected and gas X and Y combine. What pressure will this mixture be at? Note standard temperature and pressure is 0 Celsius and 1 atmosphere. And also, I think I'd like to say both a second gas, gas Y, of the same substance, but there we go, twice the volume, twice the pressure, and the same temperature. Okay, now we're good.